Hi class. In this lecture we continue our study in chapter 10, section 10.2, talking about the calculus with parametric curves by now moving into areas. Alright, so this is basically just an extension of the fundamental theorem of calculus talking about area under the curve. But okay, so we know that the area under a curve for y is equal to f of x from the bounds a to b is just equal to the definite integral from a to b f of x dx. Okay. Now, however, if the curve is traced out once by parametric equations, all right, where x is a function of the parametric parameter t and y is another function of the parametric parameter t. Here, though, notice that t is going to go from alpha to beta, not from a to b. It's a little different, okay, alpha to beta. Then we can calculate an area formula just by using the substitution rule for definite integrals as following. All right, so the area of the integral from a to b y dx, so just our original curve, all right, is equal to, now we're switching it over into the parametric equations. It's the definite integral from alpha to beta, so whatever t varies from, all right, g of t, so just the parametric function for y, times f prime of t, so the derivative of the parametric equation for the x variable, dt. All right, so the definite integral from alpha to beta, gt, f prime of t, dt. So it's just a formula that you'll straight follow to do these problems. All right, so let's just do one example. So let's find the area under one arch of the cycloid, and this is what it looks like. All right, where x is defined by the parametric equation, the radius, so whatever the radius is of this, times theta minus sine theta. So here our parametric parameter is no longer t, all right? And y is equal to r times 1 minus cosine of theta. All right, so we're not using t here, and that's okay. You know, generally when we use trig, we use theta anyways. Okay, so I've got this. I want to find the area under here for some radius r, so r is just a constant, and x and y are given by these parametric equations. All right, so one arch of this is given by, so this is where theta goes from. It goes from 0 to 2 pi. So we're going to use this for our bounds of integration and not from 0 to 2 pi r. Okay, we're just using this right here. All right, so using the substitution rule, okay, we know that y is equal to r times 1 minus cosine theta, and the derivative of x, so we've got to go back. We've got to take the derivative of this. Remember, r is a constant. So this becomes 1 minus cosine of theta when we take this derivative. So dx is just equal to r times 1 minus cosine of theta. So what we're going to do is we're just going to substitute in. We're going to go from 0 to 2 pi, r. Okay, so this right here is my function for y, my parametric function for the y. So this is just 1 minus cosine of theta times, now this is the derivative of the x function. Okay, so this is r times 1 minus cosine theta d theta. All right, so what you're going to have to do here is you're going to have to do a little bit of algebra, right? So the r times r gets r squared. That just gets factored out. And this is just the integral from 0 to 2 pi 1 minus cosine theta squared d theta. Okay, so what you're going to have to do is you're going to have to FOIL this out to get this right here, this integral. All right, so integrating this and this is trivial. Right? This just integrates as theta, okay? This cosine here, cosine squared theta, you're going to have to power reduce this to be able to integrate this. Okay, so when you power reduce it, you get the following, all right? So it's just 1/2 times 1 plus cosine of 2 theta. So now this is pretty trivial to integrate right here. So it just integrates as the following. This right here, how I got the 3/2 is the 1 plus 1/2 here. So this is 3/2 theta minus 2 sine theta plus 1/4 sine of 2 theta. And here we're going from 0 to 2 pi. Now the r squared is just a constant, so leave that out there. So you're going to plug this in, and when you do, it just simplifies to the following. 3 pi r squared. So all you did here was just follow the formula, and it's a pretty straightforward application of this type of concept.